All right, so this is going to be the next part of the introduction to rigid transformations. So same standard. So remember, we define rigidness. Okay, so rigid just means you can't change the shape or size. The shape or size is incapable of being changed because it's rigid. Okay, transformation just means changing something. And in our case, of course, it's mathematically, right? We're mathematically rotating, changing coordinates, doing all that other stuff. So we've looked at the first type of rigid transformation. That was a translation. We looked at the second type, which was a rotation. That's when we were turning stuff, right? Translation was when we were sliding. And now the third type of rigid transformation we're going to look at is reflection, okay? And reflections occur when you mirror an object over a certain point or line or axis, all right? So real quick, let's recall the axis, what the axes are in the XY plane, okay? So this is the XY plane. It's two-dimensional. It's the one that you've been familiar with so far. This is the y-axis, okay? This is the positive y direction. This is the negative y direction. The further you go down this way is the further you get from 0. The further you go up is the further is more positive, right? This way is more negative. Same thing with x. We say going right means to go positive for the x, and then go left means you get more negative, okay? So x-axis, okay? So x-axis, and then we call this one the y-axis. All right, so now what we can do is we can go back to our key concepts, which I've summarized a little bit. Okay, so rigid transformations do the following. Okay, they keep lines and line segments the same length. They keep angles the same measurement, and parallel lines stay parallel lines. All right, so real quick, let's jump into reflections and look at reflections and how they behave in the XY plane. Okay, so here we have rectangle C. Okay, angles 1, 2, 3, and 4, and we're going to reflect it. Okay, and we might as well get used to some of the terminology. So I'm going to reflect this rectangle C. Okay, this original rectangle C over the y-axis. I'm going to reflect it over the y-axis. So it's going to end up looking like this. Okay, so keep in mind where these new angles, where these new 1, 2, 3, and 4 wind up, right? So when I do that reflection and I get the new rectangle C prime, look where the 1 went to. The 1 came to the outside, the 2 came to the outside. I'm sorry, the 2 stayed on the inside, the 3 stayed on the inside, and the 4 came to the outside. So if you follow the little map, the map where the 1 falls on top of, right? The 1 falls on top of the 1, 4 falls on top of the 4 on the outside. Okay, so it's a reflection. All right, so we could do the same thing. In this case, they're rectangles, so maybe it's a little hard to see the shape of how they're changing. So let's look at this triangle J. Okay, this triangle J has angles 1, 2, and 3. All right, and I'm going to reflect it over the y-axis again. Okay, so when I reflect over the y-axis, it looks like this. It's going to look like this, a reflection, like a mirror, just like that. Okay, so if we look at this J prime, right? This is going to be the reflection of J over the y-axis. Maybe I'll write that down. This is the reflection of we'll say triangle J over the y-axis. Okay, so this is the reflection over the y-axis. Note where the where the angles end up, right? So the 1, when you flip the 1 over here, the 1 stays on the inside. Okay, the 2 flips here. But note now, the 1, it's like the triangle was pointing to the right. Okay, so now when we reflect it over the y-axis, now the triangle is pointing to the left. Okay, and I think the reflections are a little easier to see with the triangle. So let's say we wanted to reflect this triangle J now. Let's say we wanted to reflect it over the x-axis. Okay, so this is the original. Okay, now let's say we wanted to reflect it over the x-axis. Well, how would that look like? So we just reflect it just like this. So we reflect it just like a mirror. Okay, and they would look just like that. All right, so if we look here, we have this. Okay, we have this J triangle, and now what we can do is reflect it like this. So we'll have the 1. So if we pay attention, the one will be right here, right? The 1 will be here, and then the right angle right? The right angle will be up here, which was angle 3, and then angle 2 will be the one pointing downwards. Okay, so that's what we can. That's pretty much. So this we'll call this J prime since it's the image. Okay, since it's what's happening to it. Okay, so here's the original, and notice how the triangle is pointing up right now. All right, but when we reflect it over the x-axis, when we take its mirror, right, we reflect it, and now the triangle is pointing downwards. Okay, and notice the 2. Even more interesting, the 2 is pointing upwards. Okay, when we reflect it over the x-axis, the 2 angle, the angle 2 looks like it's pointing downwards. All right, so that's something we can that's something we can look a little further into, is the rotations and how we rotate over the axes. All right, so now we can go back to these key concepts because now we've developed the 3 special types of rigid transformations, okay, and what they do. So back to the key concepts, we know that translations, rotations, and reflections, they all keep lines and line segments the same length. Okay, that's very important to remember and to conceptually grasp, right? So the next one, letter B, or concept B, is they keep angles the same measurement, right? So no matter how we reflect this, if I reflected the triangle like this, right, angle 1 still stayed the same, right? It's not like I squeeze the triangle or increase the triangle in any way to change the measure of angle 1. Angle 1 is just changing its position. Okay, so first it was here in this quadrant, now it's going to be in this quadrant. Okay, the measure of it's still the same. Same thing with the 3, right? The 3 was a right angle. Now when I rotated it, it's still a right angle. Okay, so it's not, the measure of the angles aren't changing. Okay, so the measure of the angles is being preserved, keeps the same measurement. And for parallel lines, stay parallel lines. Maybe we don't really have parallel lines here, but if we bring the rectangles back in, okay, even if I reflected this, let's say I reflected this this rectangle over the x-axis. So right now we have 1 and 4 being parallel, right? So 1 and 4, 1, 4, and 2, 3 are parallel, right? And 1, 2, and 3, 4 are parallel, right? So what we could do is maybe we reflect it over the x-axis. Okay, so if I did that, let's see what would happen. So this is C prime. Okay, let's put C here. All right, so we put C here, and what I can do is I can reflect it. So let's see where these angles end up. Angle 2 looks like it's going to be, when I reflect it over the x-axis, looks like angle 2 is going to be down here in this bottom right corner. Okay, and looks like angle 3, when I reflect it, it's going to be right up here. Okay, it looks like angle 1, when I reflect, it's going to be down here, right? And still being next to the 2. That means angle 4 will be here, and we'll have C prime. All right. So this is what the rectangle will look like if it's reflected over the x-axis. Okay, the 1 and 2 that are on top right now get reflected, and now they're on the bottom. The 4 and 3 that are on the bottom, they get reflected, and now they're on the top. Okay, but despite where their positions are, we still have the parallelism, right? 2, 3, and 1, 4, 1, 4, and 2, 3, they're still parallel. Okay, 3, 4, and 1, 2, 1, 2, and 4, 3, they're still parallel. Okay, so we preserve parallel lines. So that means parallel lines stay parallel lines. Okay, parallel lines stay parallel lines. And this is all because of this special thing right here, rigid. Okay, rigid transformations do all of these things. Okay, no matter what you do. Okay, so now what do we know? So now that means we know that any combination or sequence of rigid transformations okay, so what are the rigid transformations? That means any combination or sequence of translations, rotations, and reflections preserve the length of line segments, angle measurements, and keep parallel lines parallel. Okay, so now we have all that. So what exactly does this mean? That means we can combine reflections, we can combine rotations, and we can combine translations in any way, shape, or form. So no matter what we do, so let's say we had this C. Let's say we reflected it across, and we rotated it 90 degrees, then I translated it 3, 4, 5, 6 times, and I switched it back over, and maybe flipped it over to the origin again. It doesn't matter. I can combine all of these reflections and rotations and translations, and no matter what I do, as long as I'm doing these transformations, reflections, translations, and rotations, that all of these key concepts will still hold true. Okay, the lines will stay the same length, the angles will stay the same measurement, and the parallel lines will be mapped to parallel lines. Okay, so that's going to do it for this standard and the introduction to rigid transformations. And in the next videos, we'll start practicing and maybe diving a little further into some non-rigid transformations and maybe some other pretty neat material. All right, see you guys in the next videos. Thanks.